Connecting Universal Design for Learning with the Neuroscience of Learning, a webcast presentation by the Universal Design for Learning project at the University of Vermont. Universal Design for Learning is an approach to designing inclusive learning environments. By employing research-based UDL principles to plan their teaching, higher education faculty may successfully teach a wider range of students. UDL principles are 3 in number: multiple modes of representation, the way faculty present their content to students; multiple modes of action and expression, the ways faculty permit students to show them what they are learning; and multiple modes of engagement, the way faculty motivate student involvement and interest in their subject matter. This webcast will show how the UDL principles are based upon the activity of brain systems that are involved with the learning process. The last 20 years have seen an explosion in methods of accessing brain function, particularly with the employment of different imaging techniques. We are now able to see in part how the brain functions for different learning tasks. Notice how the different parts of the cerebral cortex are involved in different types of task. Functional MRIs can also show that individuals use their brain in different ways depending on their familiarity with a given task. This particular image shows the difference in brain use for a reading task for someone for whom the task is new and someone for whom the task is old hat. The naive or practiced reader is experiencing significant work in their frontal cortex, the part of the brain used to problem solve and process new information. The practiced individual shows little burn in the same area. Both individuals show some activity in the temporal lobes, the repository of prior knowledge, though once again, the unpracticed individual is working harder in that important area. Research using functional MRIs and other imaging techniques have revealed the brain systems that are most responsible for learning tasks. The recognition system is the system that is involved in the integration and storage of new knowledge into previously constructed neural structures. In short, our long-term memory structures. Our prior knowledge of the world around us and the things we study in class are processed in the recognition system. The recognition system resides in the back brain, including the temporal lobe. The strategic system is our active thinking system. It is the place in our brains where we problem solve and hypothesize, the place where our working memory operates to create new ideas and plans and knowledge. It is the place where new knowledge moves from idea to event through activity, and is located in the frontal cortex and includes the motor area of the cerebrum. The last and third system in the learning networks is the affective system. Located in the limbic area of the old brain, the affective system propels learning. It is the motivational center of the brain and is intimately connected to both the recognition and strategic systems. It is a place of emotion, and it is where learning is inspired, or not. Research carried out by CAST, the Center for Applied Special Technologies, has shown that each UDL principle connects to the activity of one of these brain systems. When a teacher presents content material in several different ways, she is using multiple options of representation. The fact that her students experience what it is she is teaching in several different formats helps tap the multiple ways the recognition system stores information, thereby creating additional learning opportunities for their successful acquisition of content. The same idea applies when this teacher allows students to use multiple mediums to show her what they're learning from her. This use of the UDL principle of multiple means of expression means students have choice in how they put their learning into play and this creates additional learning opportunities for their demonstration of content acquisition. Multiple options of expression originate in the strategic networks of the brain system. Finally, this teacher may have students working in groups to create presentations or working on a wiki together in Blackboard to write one answer to a question she has posed. Her designing ways for students to interact with each other to address challenges she has put to the class means the student's affective system has been tapped, thereby engaging the student's interest and motivational capacities to do well with each other. Brain imaging is helping us better understand how to use the UDL principles to design learning experiences for the varied groups of learners who walk in our classroom doors every day. Applying UDL principles to the problems inherent in large class instruction have resulted in reconfigured classrooms. The Scale Up project has just this challenge as its focus. This is a good example of how UDL principles and what we've learned from the brain systems interact to create richer learning environments. Thinking about what was needed to create multiple options for representation, expression, and engagement in large classroom settings led to the development of classrooms set up in ways that promote student interaction and variety in classroom presentation. This picture shows one such classroom. Note the small group configurations, each group having at its disposal computer technology that permits collaboration and technological projection to the group and to the class. The faculty workstation is situated in the middle of the groups, and the technology available to faculty assists them to see what's going on in any group and to post any group's work so all can have at it should they want to. Ongoing research is showing that UDL, informed by the growth of neuroscientific findings about how the brain learns, is leading to better designed courses and more robust student learning. Further information can be obtained by contacting the UDL at UVM project at the University of Vermont. Thank you for listening.